First, we're going to talk about what is work. Work is a scalar quantity and is defined as the product of an applied force and the displacement of an object in the direction of the applied force. Then, we're going to talk about work done by a constant force. If the force and displacement in the same direction, we're going to use this formula, which is W equals to F multiplied with S. The SI unit for work is joule. 1 joule is equivalent to 1 Nm. In other case, when the applied force on an object and the direction of movement of the object is not the same, then work done can be calculated by the formula of W equals to F cos multiplied with S.
What work done against gravity? Work done against gravity is when you lift an object upwards. You are working against the force of gravity. Gravity wants to pull the object down, but you are applying an upward force to move it higher. This action requires energy, which is the work done. So, formula for work done against gravity is W equal to M multiply G multiply H. W is work done in joules, J. M for mass of object in kilogram. G is for acceleration gravity, which 9.81 meter per second. H is for height the object is lifted, which in meter.
Work done against friction. Let me explain what work done against friction means. Whenever we push or pull an object across a surface, like dragging a chair across the floor, we are not just moving it, we also have to overcome a force that resists that motion, and that force is called friction. The energy we use to fight that resistance is what we call work done against friction. This energy doesn't disappear, instead is converted into heat and sometimes even sound, which is why you hear a scraping noise when moving furniture. The frictional force is calculated using this formula. F equal to mu n, where mu is the coefficient of friction and n is the normal force, which is usually the weight of the object pressing down on the surface.
Sorry for being late and keeping you waiting. Are you okay? Tired. I'm just fine. But why do you look so tired? Oh, I just helped our lecturer to lift so heavy boards when I'm on my way to come here.
Oh, I see.
Wait, since I know you are good at mechanics and physics, I have one question for you. Why do I feel it's so heavy and why does it make me feel so tired?
Oh, that's easy. Let's see how much work you have done.
Huh? Work? Like spreading wood?
Yes, but basic stuff. So, can you give me some details about the work you have done?
Alright. So, I think the mass of the box might be 5 kilogram.
Heavy.
Yeah, and I put it up on a scale at 15 degrees, I would say. And the distance is like 0.75 meters. So that's all. So let's see how you calculate it. Let's go.
Do.
To calculate the work done against gravity, we first need the component of the weight acting along the slope that is given by W equals to M multiplied with G multiplied with sin theta and multiplied with S, where M is the mass equals to 5 kg, G is acceleration due to gravity equals to 9.81 ms, E is the angle equals to 15 degrees, S is the distance equals to 0.75 meters. So we calculate W multiplied with 5 multiplied with 9.81 multiplied with sin 15 multiplied with 0.75 equals to 9.52 joules. This is the energy required to overcome the component of gravity, pulling the object back down.
Okay, that's all.
Wow, so it takes 9.5 joule just to fight gravity?
Exactly. Next, we calculate the frictional force.
Okay, let's go.
Next, we calculate the work done against friction. The frictional force on an incline is given by force equals to mu times R, where mu is the coefficient of friction equals to 0.4 and R is the normal reaction equals to mg times cos theta. So R equals to 5 times 9.81 times cos 15 equals to 47.3787 Newton.
and frictional force equals to 0.4 times normal reaction, and finally we get 18.95148 Newton. Now, the work against frictional force is 18.95148 times 0.75 equals to 14.21 joule. This represents the energy needed to overcome the frictional resistance.
Okay, I'm done.
Wow, more work against friction than gravity?
Yup, that's why things feel harder to start than me sometimes.
Oh, I see. Thanks again for the math. Now I know why you always with calculator.
Welcome.
In conclusion, work done against gravity and work done against friction are two essential applications of the work energy principle in physics. When an object is lifted vertically, work is done against the force of gravity, and this energy is stored as gravitational potential energy. On the other hand, when an object is moved across a surface, work is done against friction, and the energy is mostly transformed into heat and sound due to surface resistance. Understanding these two types of work helps explain how energy is transferred and used in everyday activities such as lifting, dragging, or pushing objects. It also emphasizes the importance of direction and opposing process in calculating total work done on a system. These concepts are fundamental in mechanical physics and crucial for solving real-world engineering and motion problems.